The objective of this lesson is to solve problems using the knowledge and understanding of surface area. In previous lessons, students used nets to determine the surface area of a variety of three-dimensional figures. Today, students will extend their knowledge to real-world situations where it is not necessary to include all of the faces. There are multiple ways to calculate the total surface area in today's lesson. A cake decorator created a cake with 3 tiers. Each tier is a rectangular prism and is covered on the sides and the top with sheets of white fondant icing. The decorator estimates that 2/10 ounces of fondant are needed for every square inch of the cake's surface area. How many ounces of fondant should she expect to use to cover the entire cake? Use the table below for the dimensions of each layer. Let's begin by drawing each rectangular prism tier. Below each tier, let's draw the nets and label the faces with back, top, front, bottom, left side, and right side. The sides will need to be labeled so the bottom of each tier is not included in the total surface area, since fondant will not be used on the bottom of each tier. Next, label each face with the dimensions in order to calculate the surface area. Let's start with the bottom tier. The back face will have the dimensions of 6 inches by 14 inches for a total surface area of 84 square inches. The next face is the top. The top has dimensions of 14 by 14 for a total surface area of 196 square inches. The next face is the front face, 6 by 14. The left and right sides have dimensions of 14 by 6, and each has a surface area of 84 square inches. The total surface area needed for the bottom tier is 84 plus 84 plus 84 plus 84 plus 196, or 4 times 84 plus 196 equals 532 square inches. Continue calculating the surface area for the middle and top tier. The middle tier's surface area needing fondant is 60 plus 60 plus 100 plus 60 plus 60, which equals 340 square inches. Notice that on the top tier, all the dimensions are the same. This is because the top tier is a cube, and each face on a cube is a square. One way to calculate the surface area would be to add each face of 36 plus 36 plus 36 plus 36 plus 36 equals 180 square inches. Another way would be to take the dimensions of 6 by 6 equals 36 square inches and times it by 5, because there are 5 faces of the same dimensions getting fondant. 36 times 5 equals 180 square inches. Now that the surface area for each face of each tier has been calculated, let's add up all the surface areas to get a total surface area for the entire cake. 532 plus 340 plus 180 equals 1,052 square inches of fondant. The problem states that 2/10 of an ounce will be needed for every square inch. In order to find out how much fondant will be needed, the surface area must be multiplied by 2/10. One way would be to multiply each tier's surface area by 2/10, then add the total together. 532 times 2/10 equals 106 and 4/10. The middle tier is 340 times 2/10 equals 68. And the top tier is 180 times 2/10 equals 36. Now add the ounces of fondant for each tier together. 106 and 4/10 plus 68 plus 36 equals 210 and 4/10 ounces of fondant needed. Another way to get the total amount of fondant needed would be to add the surface area of each tier together and then multiply the sum by 2/10. 1,052 times 2/10 equals 210 and 4/10 ounces. The objective for this lesson was to solve problems using the knowledge and understanding of surface area. We met this objective by calculating the amount of fondant needed on a 3-tier cake. We found the surface area, not including the bottom, of each tier by drawing the nets for each layer. Then we multiplied the surface area by the amount of fondant needed for each square inch.